Good morning, everyone. Today we are going to discuss about wind energy. The wind energy is under the syllabus of renewable energy technologies. The subject code is CME 365. First of all, introduction about wind energy. Wind energy is essentially air in motion which carries with its kinetic energy. The large amount of kinetic energy contained in the wind at any given instant is proportional to the wind speed at that time. Wind results primarily unequal heating of the earth's surface by the sun. About 2% of total solar flux that reaches the Earth's surface is transferred into wind energy. During the time, the air overall land mass heat surface air overcomes ocean. How the power in wind? Wind possesses energy by virtue of its motion at any device capable of slowing down the mass of moving air like a sail or propeller can extract part of the energy and convert into useful work. There are three factors that determine the output from the wind energy converter. First one, the speed of the wind, then the cross section of wind swept by rotor, then the overall conversion efficiency of the rotor, transmission system, generator or pump. The total power of the wind stream is equal to the time rate of kinetic energy. Already we know that the formula of kinetic energy equal to half mv square. The amount of air passing the unit time through an area with velocity. So the mass equal to AV meter cube per second. Mass of the flow rate M equal to rho A, where rho is the density of air. So kinetic energy equal to 1 by 2 rho AV into V square. Basic components of the wind energy conversion system. The main components of wind energy conversion system in the form of block diagram. Wind energy conversion system convert wind energy into sum of the electrical energy in particular medium. On large scale, wind energy are designed to operate in parallel AC grid. This is known as grid connected system, a small system isolated from feeding only to local known as autonomous or isolated power system. Wind energy conversion system diagram. This is a diagram for wind energy converter system. Then types of wind energy. According to orientation of the axis of rotor, it is depending upon the rotor, the wind can be classified two types. Orientation of the axis of rotor and according to useful electrical power output. First one, horizontal axis. When the axis of rotation is parallel to the airstream, the turbine is said to be a horizontal axis wind turbine. Simply it's called as HAWT. Then second one, vertical axis. When the axis of rotation is perpendicular to the airstream that is called vertical. The turbine is said to be a vertical axis turbine. According to useful electrical power output, small output can be up to 2 kilowatt, medium up to 2 to 100 kilowatt, large output more than 100 kilowatt, large, large output more than 100 kilowatt. Types of wind energy. According to the type of rotor, propeller type, it is horizontal axis, high speed rotor. Multiple blade type, it is horizontal axis, low speed rotor. Chauvinist type, it is vertical axis rotor. Darius type, it is vertical axis rotor. Horizontal axis wind turbine. Simply it is called as HAWT. Horizontal axis machines have emerged as the most successful type of turbines. These are being used for commercial energy generations in many parts of the world. They have low cut in wind speed, easy fulfilled in general, show power coefficient. However, the design is more complex and expensive as the generator and the gearbox are to be placed at the top of the tower. Also, a tail or yacht drive is to be installed to orient them into the wind direction. This is a diagram for horizontal axis wind turbine. Site selection concern. How to select the site? First one, average annual wind. First, we are going to calculate the average annual wind speed. The power available in wind increase rapidly with the wind speed. Therefore, the main consideration for locating a wind power generation plant is the availability of adequate and uniform average wind velocity throughout the year. The total wind power from free wind stream increases as the cube of the wind speed. Therefore, wind velocity available should be the range of 5 meters per second to 25 meters per second throughout the year. Then we are going to select the area. As the building forest offers the resistance to the air movement, the wind farm and located away from cities and forests. Flat open area should be selected as the wind velocities are high in flat open area. Then altitude of the site. Altitude of the proposed site should be considered. Higher altitude good ground experience strong winds. The lower altitude, thus altitude affects the electric power output of wind energy conversion system. Wind velocity must be measured by anemometer at several heights from the ground. Wind structure. At the proposed site, wind should blow smooth and steady all the time. That is, the wind velocity curve should be flat. Wind specifically near the ground is turbulent and gusty and changes rapidly in direction and in velocity. Local ecology. Small trees, grass and vegetarians are present, all of which distract the wind. Then the height of the tower will increase, which increase the cost of the system. Next, nature of a land and its cost. The site selection should have high load bearing capacity, so it would reduce the cost of foundation. The cost of the land should be low to reduce the initial cost. Transport facility. These should be the transport facilities for transportation of heavy machinery, structures, material, blades, etc. to choose site for the installation. This is the introduction about our wind energy. Okay, thank you, my dear students.